Hello everyone and welcome back to my channel. In this video, we will be solving another geometry-related problem. So today, we are given this quarter circle, which consists of these two semicircles, this one being slightly larger in size than this one. And now, we are required to find the area of this red shaded region. And notice that we are also given this 6 meters, which is essentially the radius of this whole quarter circle, and also the diameter of this semicircle. So, first of all, let's label these areas using variables. For example, this semicircle as A1, this as A2, the red shaded region has A, and lastly, the whole quarter circle as AQ. Now, the main concept behind solving this problem is that we need to subtract the areas of these two semicircles from that of the whole area of this quarter circle, so we can formulate this by setting up the equation, which is E is equal to EQ minus E1 minus E2. Now, let's move on to the second part of these problems, which is finding the values of these respective variables. So, here, let's start off by finding the value of AQ. And in order to find it, we need to set up this formula. EQ is equal to 1/4 by R squared. The reason for writing 1/4 here is that the whole figure is basically a quarter circle, for which we would need this 1/4 pi R squared value. So now, if we input the value of R, or the radius of this quarter circle, then we get here 6 squared. And simplifying, it gives us 9 pi, which is basically the area of this quarter circle. And substitute that here, and we're done finding the area of this quarter circle. And now, let's move on to finding the area of this semicircle A1. And in order to do that, we would need a slightly different formula than this one. And that is A1 is equal to 1/2 by R squared. And the reason for writing 1/2 here is that this semicircle is basically a half circle. And in order to find the areas of half circle, we need to divide the formula by 1/2. And then finding the radius. As I have already mentioned, that this whole region or this whole side is basically the diameter of this semicircle. So if we divide the diameter by 2, then we get 3 meters, which is essentially the radius of this semicircle. So here we would simply input 3 squared. And then simplifying, it gives us 9 pi divided by 2, which we can simply plug in here. 9 pi divided by 2. And now, lastly, we would need to find the area of this semicircle is A2. And in order to find it, we would need to find the radius or the diameter of this semicircle, which is not given in this question, unlike the diameter and the radius of this quarter and semicircle respectively. But here, we can draw a tangent line because this region is tucking each other, and when two arcs of a circle intersect with each other, then we can simply draw a tangent line. And then we can draw another line from here and the second from here to here. Now notice that this is basically the radius of this circle, and this is the radius of this semicircle. And we know that these two radius from this point of this semicircle to this center of this semicircle is basically a straight line because it is perpendicular to this tangent line. And now, to make it even more clearer, we can simply erase this tangent line and immediately notice that this whole region is now a triangle, or to be preciser, a right angle triangle, with this side being 90 degrees. And then we can level this radius as r and this whole radius as 6 meters because it is also a radius of this same quarter circle. And then as this radius, or this side is also the radius of this semicircle, so we can write 3 meters here and also r here. And then using the Pythagoras theorem, which is e squared plus b squared is equal to c squared, we can set up that 6 minus r whole square plus 3 square is equal to 3 plus r whole squares. And then here, 36 minus 12r plus r squared plus 9 is equal to 9 plus 6r plus r squared. Simplifying it even further gives us, so 36 is equal to 18r, which we can see it here. For example, if we cancel out this to 9th and r squared, and then we're essentially left with 36 minus 12r on the right side and 6r on the left side. And then we can carry the value to here and simply get this value 18r. And then simplifying it even further gives us 2 meters, which is basically the radius of this whole semicircle. And now our last task is to find the area of this semicircle. And if we input the value of this radius, then we get did 2 is equal to 1 by 2 pi cube square, and simplifying it gives us 2 pi, which we can substitute in this equation 2 pi. Now, if we take q as LCM, then we get here 18 pi minus 9 pi minus 4 pi. And now if we subtract these values, then feed 5 pi divided by 2 meters, and it is essentially the area of this shaded region in fractions. And if you want to write it in decimal, then it is 7.55 meters. And that is basically our final answer. And hence we can say that we have solved this math problem. So, if you have enjoyed this video so far, then make sure to like the videos and subscribe to this channel. I would appreciate it a lot. Then, till next video, bye!